Hey everyone, in this video we're going to be taking a look at proportions. So first of all, what is a proportion? Well, when we have two rates or ratios equal to each other, then the equation that expresses the relationship is called a proportion. So for example, if we have the ratio 3/4, right, this is 75%. You could write this a couple of different ways here. We could equate this to being 6 divided by 8. Okay, so this equality between these two ratios is a proportion. So we could say the fraction 3/4 is proportionate to the fraction 6/8. These two are the same things. It doesn't matter how we express it. Okay, so we're going to go over a few examples. We have 4 examples here that are going to have some ratios in there we need to set up, and we're going to express the equality between some of these ratios to obtain a proportion, and then we're going to try to solve for a missing variable somewhere within the proportion. So let's begin by taking a look at example number 1. So suppose it costs you $24 to fill up 8 gallons in your car. How much will it cost someone to fill up 13 gallons? Now, some of these have some fairly easy numbers, and you may be able to do these in your head just fine, but I would encourage you to understand the way we could write this down on paper. Certainly for more difficult numbers, it's not as easy to do in your head. So you want to understand how to set up the proportions in order to solve for the missing variable. So first of all, you may think, all right, if it costs you $24 to fill up 8 gallons, we're saying that's going to be $3 a gallon, right? So in order to fill up 13 gallons, we would expect that to cost $39. So we could have an answer in mind before we begin, but in order to set up the proportion, we want to do some comparisons here. So for example, to fill up 8 gallons, so we could get 8 gallons for every $24 spent. Okay, and we could equate this to another ratio. So for 13 gallons, how much money do we have to spend? In this case, we're saying X dollars. So the ratio 8/24 is proportionate to the ratio 13/X. So I'm comparing gallons to dollars here. And if I set up my ratio like this over on the left side, I have to do the same thing over here, comparing gallons to dollars. Now there's going to be more than one way to correctly set up this problem, but let's go ahead and see if we could solve for X in this case. So let me drop my units here. We have 8 divided by 24 is equal to 13/X. So when we want to solve for X in this case, if you have a variable in the denominator, you want to try to get it out of there somehow. And eventually what you'll need to do is you'll need to multiply by the variable on both sides. So in this case here, if I multiply by X on the right side, these two will cancel, and I have to do the same on the left, like this. So my new equation is now 8X divided by 24 is equal to 13. Next, I want to get rid of my 24 here. There's a couple ways to do this here, but I suppose we could go ahead and multiply by 24. You know, actually what would be easier here is instead of writing 8x/24, the fraction 8/24 reduces to 1/3. So instead of writing this, I'm going to go ahead and write x/3 is equal to 13. Okay, I just reduced that fraction. That's going to make the work a little bit easier for me here, so I went ahead and did that. And I encourage you to do the same. You know, if you see any simplification you could do throughout the problem, you could go ahead and do so, and it's going to make the work much easier. So now we have this. We're trying to solve for x, so we need to get rid of the 3 here. So we would multiply by 3 on both sides. So we have x is equal to 39. And the units on there is dollars. And that's the answer we expected, right? Because if it's $24 to fill up 8 gallons, that's $3 per gallon. So we would expect 3 times 13 to get $39. Now this was one way to set up the proportion. You could have just as easily said, okay, with $24, I can get 8 gallons. And this would be equal to, well, how much money would I have to spend to get 13 gallons? So this would be another correct way to set up the problem here. So that would be just fine if you did that as well. And I believe there's another way as well, but we'll just stick to these two here. We'll stick to these two cases. So either way you want to set these up. So moving on. Oh, well, you know, let's go ahead and solve this. 24 over 8, we have 3. And this is equal to x over 13. And then we want to solve for x here, so we would multiply by 13 on both sides. So we get 39 is equal to x. And of course, this is dollars here. So as long as you are consistent in the way you set up these ratios, we should get a correct answer. It shouldn't matter how we set these up. Although you do want to be careful, we can't throw numbers everywhere. Again, you want to be consistent in the way you're comparing things here. So for example, if I said, it's $24 for 8 gallons, I couldn't set up the ratio over here, 13 gallons per how much money. Okay, in this case, I was comparing gallons to dollars, so again, I have to compare gallons to dollars over here like that. So now in example 2, in a certain recipe, we have 3 cups of flour are needed to serve 8 people. So how many cups of flour would be needed to serve 20 people? And this is probably something we've all had to do, like doubling recipes and so forth. So if 3 cups of flour are needed to serve 8 people and we need to serve 20, well, that's 2.5 times 8. So we would expect 2.5 times 3 cups of flour to be needed to serve the 20 people. But again, we want to have an idea on how to set up these proportions. So we could say, so with 3 cups of flour, we can serve 8 people. So for every 3 cups, we could serve 8 people. And this should be proportionate to x cups for 20 people. Okay, we would expect the ratios to be equal to each other here. So now we want to go ahead and solve for x. We don't need our units when doing the work, so we could just write 3 over 8 is equal to x over 20. And now we want to solve for x, so we need to move this 20. So we need to multiply by 20 on both sides. And that gives us 60 divided by 8 is equal to x. And we just need to reduce this fraction here. So this would be 15 over 2 because 4 goes into 60 and it goes into 8. So we would get 15 over 2. and this is cups of flour. Okay, or we could say 7.5, but we'll just leave it 15 over 2 is equal to x. Okay, so 15 over 2, 7.5 cups of flour. And that's exactly 2.5 times 3, right? Because to serve 8 people, we needed 3 cups, but we're serving 20, so that's 2.5 times 8. So 2.5 times 3, we get 7.5 or 15 over 2. And if you set this up another way, you could set it up, let's say for every 8 people, you're going to need 3 cups of flour. And this would be equal to, now since I'm comparing people to flour, I'm going to do the same thing over here. So for 20 people, how many cups of flour would be needed? So we could do this ratio set up here. I mean this proportion here. So in order to solve for x, we would need to multiply by x on both sides. So we have 8/3 x is equal to 20. Now, one thing we could do here is multiply by 3 and then divide by 8. So I'll go ahead and do it like that, because we need to move the 3 over here. So we get 8x is equal to 60. And lastly, division by 8. You see we're going to get the same thing, 60 over 8, right? So x is equal to, and we know 60 over 8 reduces to 15 over 2. And again, we know this is cups of flour. Okay, and so there's another way to set up this ratio too, but I prefer these two methods here. You may want to see if you could find the other correct way to set up this ratio to obtain your answer. There's oftentimes, there's so many ways to think about these in terms of mathematics. We could do things multiple ways and still get the correct answer. But you just need to make sure that the way that you're doing this is mathematically valid and that it makes sense and that the method was not just a fluke. Sometimes that could happen. So in example 3, I call this a sampling problem. So in these sampling problems, these are usually a way to estimate populations of animals. So biologists captured 20 penguins and they tag and release them. So 20 of these penguins in the wild have some kind of marker on them. And later the biologists return and find that 4 are tagged and a sample of 17 penguins. So the biologists later came back and in the same area they caught 17 penguins and they see that 4 of those penguins are ones that they have captured earlier and they tagged. The other 13 penguins were not tagged. So we want to estimate the penguin population in the area. So, this would be more accurate the more penguins you could work with. With these small numbers, it may not be accurate, but if you're in a small area, this sampling could be used to estimate the population. So we have 20 tagged penguins out of the entire population. Okay, so we can compare 20 tagged penguins. We're going to set up the ratio here. So what percentage of these penguins are tagged? Well, it would be 20 divided by the entire population. So let me just write that out. The entire population. And this should be equal to the ratio that we found here. We have 4 tagged in a sample of 17. So a little bit less than 25% were tagged. So we have 4 tagged penguins, and we're comparing this to our sample, which was 17 penguins. Okay, so I'm comparing the tagged penguins basically to my sample, right? Tagged penguins compared to my sample. In the case of 20 tagged penguins, my sample is actually the entire population. So this ratio, let me drop the units here, could be written as 20 over x is equal to 4 over 17. This would be one way to set it up, or we could say x over 20 is equal to 17 over 4. That would be another correct way to set it up. And I'll just do it like this here, and we'll go ahead and solve for x. So one phrase you may have heard at this point is cross multiplication. Now, cross multiplication only works really when you have a ratio like this equal to another ratio. It's not any magical trick or anything. It's really just following the basic rules of equation solving. What it says that is if you have a situation like this, we could cross multiply and obtain 340 is equal to 4x. And I don't like to use it too much. It depends on the situation and where the variables happen to be. So I just use, we should still just follow the basic rules of problem solving to solve a proportion like this. So the idea is to get x out of the denominator. So we multiply by x on both sides so that they cancel on the left, but on the right side we'll have an x in the numerator. So now we have 20 is equal to 4x over 17. Now we may want to move the 17, so if we multiply both sides by 17, we have 17 times 20, which is 340, equal to 4x. And lastly, we want just x, so we want to divide by 4 on both sides. And now 340 divided by 4 would be 85. So 85, and this would be penguins, is equal to x. So 85 is an estimation of how many penguins would be in the area. Because if we had 4 tagged penguins out of 17 that we caught, it's a little less than 25%. So assuming that ratio holds, then we would assume we tagged a little bit less than 25% of the penguins in the entire population. Okay, so if you flipped the ratios, so if you said x over 20 is 17 over 4, you should still obtain 85 penguins as your estimation for the population. Now, moving on to example number 4. So example number 4 involves work rate, and I talked about work rate in an earlier video. Just to remind you, work rate is equal to the amount of work done divided by the time it takes to do that work. And we also have something called combined work rate if 2 people are working together. So we're going to need that in this case. But what we have is that Jim mows 1 lawn in 2 hours. Okay. So let me write down that information. So Jim, his work rate is, I'll abbreviate that WR, is 1 lawn in 2 hours. Now Eric mows 1 lawn in 3 hours. So let me write that down as well. Eric, his work rate is going to be one lawn over 3, 1/3. Now how long would it take them to mow 1 lawn if they worked together? Okay, so the combined work rate would be the work rate of Jim plus the work rate of Eric. So the work rate, let me say WR, and let me do sub C, so that's combined work rate, would equal the work rate of Jim plus the work rate of Eric. Okay, so the work rate should equal the combined work rate would equal 1/2 plus 1/3. And so what do we get for this combined work rate? How fast could they work? Well, when we want to combine this is going to be 3/6 plus 2/6 is equal to 5/6. Okay, now that's not what the question is asking, but we're going to need this information here. So because we know that they're working together, we wanted their combined work rate, which would be 5 lawns in 6 hours. So 5 lawns in 6 hours. But what we want to know is how long it would take them to mow 1 lawn. Okay, so 5/6, 5 lawns over 6 hours would be proportionate to 1 lawn over how many hours? Okay, so this is how we set up the proportion in this case. We needed to do a little bit extra work, and we needed to remember this formula here, work over time. And then we needed to remember that if you want combined work rates, you would add their work rates together, and in this case we get 5/6. But we want to find out what 5/6 is equal to when your numerator is 1. So what would x be? Well, we want to go ahead and solve for x. So we need to get this out of the denominator by multiplying by that variable. So we obtain 5x divided by 6 is equal to 1. And then we want to get the 6 out of the denominator here. So we go ahead and multiply by the 6 on both sides. So we get 5x is equal to 6. And lastly, we want just an x here, so we would divide by 5 on both sides. So we get x is equal to 6/5 hours. So 6/5, that's a little bit more than 1 hour. You could convert this to hours and minutes if you'd like, but if they're working together, in order to mow 1 lawn, it would take them just over an hour to do that. Okay, so this video has been about proportions. Go back and click on any of these links here on the left side if you're confused about any of the setups, and maybe you could try to find if you could do these a different way. But yeah, certainly stick with the ways that we did here. But if you wanted to do some extra work, maybe take a look at example 1, 2, and 3 and see if maybe you could find a different way to do that. So I hope you enjoyed this video, and I'll see you in the next one.